In this problem, we'll be taking a look at a one-tailed t-test with a very small sample of raw data. I'll look at a method using Stapplet.com as well as Desmos so we can look at the inner workings of the problem as well. In this problem, we have a claim that the population mean is under 87.4, and here we have a sample of 6 quantitative data points that we will use to test that claim. This is going to use a t-test, which is an extension of the central limit theorem and the sampling distribution of the sample mean. So we theorize that a normal distribution, which we have here, will be fairly predictable when we look at samples compared against other samples, all in measuring the sample mean. So we're going to imagine a bell curve, and we'll even be able to see a plot of that with our Stapplet. This is Stapplet.com. And then on that bell curve, we're going to want to plot where our sample is in relation to that null hypothesis. We could use the normal distribution Stapplet, although they've created this quantitative variable Stapplet that works really a lot better for us since we have this raw data. You can use this entering the mean and standard deviation or raw data. For most of the problems that you'll come across, it'll be one of those two. And that's what I'll paste in here is this little list of data. You can set a name if you want. Here we don't have any context to the problem, so I'm just going to leave that blank. Since it's such a small data set, really visualizing with any of these graphs isn't really going to be that helpful. We'll just go straight down and check out our summary statistics. It's nice to get an initial comparison using that sample mean. Here we are under 87.4 with a mean of 71.35. It's going to come down to the standard error and that sampling distribution to see where we land there. What we want is a one sample t-test for the population mean, mu, and then we'll enter in our left tail and our hypothesized mean of 87.4. Now we've got our result here. We won't be able to visualize it yet until we use that t-score. This t is negative 3.419 with 5 degrees of freedom. In this case, that's just n minus 1. So if you did want to visualize that, you should go to Stapplet. And now we can use the t-distribution using that outputted t-score. And in this case, we're going to calculate the area under the curve and use our 5 degrees of freedom. This was a left tail test. And we should be able to see the same quantity that we've got for our p-value back here. Now it doesn't quite match because of some rounding. So why don't I adjust the preferences and make that a decimal with 6 digits of precision. Looks like we probably maxed out at 4 there, but it is nice that we get a little bit more precise area, 0.0094, when this one rounds to 3 decimal places. I'm not sure why they did that. Back here we can enter in our answers. And we had to compare that p-value to the level of significance that's been selected up here, that's 0.01. This is slightly smaller. And that lands us in the rejection region. If we want to visualize that, we see that 0.01 would shade a little bit farther to the middle of that, and our t arrowing in is arrowed inside the rejection region. We could also find a critical value for our rejection region if we instead calculate the value corresponding to the area. We were given a left tail area for our critical value of 0.01. And there we see that our critical value is negative 3.365. And here we're just slightly farther to the left, 3.419. So our test statistic t measures how far this sample of 6 is in relation to the null hypothesis all the way up here. So we sort of plug that 87.4 right in the middle. We consider how spread out the sample is to determine how spread out in theory we think those population means will be using standard error, central limit theorem. And we can see all of those steps happening with Desmos. I'll finish up these answers first. If we're in that rejection region, we reject the null hypothesis, and we provide sufficient evidence to support the claim with that sample data set. Now, if we want to see the inner workings, I just Googled t-test in Desmos. I found this t-test. I'll share the link to this in the description and any companion document I have there. Here we'll put in those same parameters. We had 87.4. Now, instead of typing in a sample mean, let's just find the average of this data set right here by little m. I'll type average. That one doesn't come up like it does in Excel. So why don't I use the keyboard functions here? Find that one. Looks like we use the word mean for those. And it started out in a box. So that didn't go inside the parentheses for me. And I did get that correct mean there, 71.35. Maybe since I removed that box, this will work better to also find the standard deviation. Again, I'll go to my functions. And standard deviation without the p is for a sample, which is what we've got. And now we're going to be using very precise statistics instead of just rounding for those. This is finding the degrees of freedom. I need to make sure that my n is correct. That one should be 6 here. And we get standard error for this resulting sampling distribution. We've got a t-score for our sample. And we have a very, very precise measurement for our left tail p-value. And this has a couple different versions, left area and right area. The downside is if you have a two-tailed test, that's not really covered there. And one last thing that you can do with Desmos, here I just opened up a blank graph and I used this t-test command, which does want the list to be in a box. That's the first input, and then a comma, and then the null hypothesized mean. We don't get any t-score. This goes straight to a p-value and it just outputs them rounded. So that's not quite as ideal. I really liked this t-test distribution that we have, and they even shade it with a red and purple. We can't really see it because it's so small, but there it is. And we can kind of see right about where that t-score is.